Hello, we are now going to talk about the topic of set notation. Now, let's talk about what is a set before we jump into what their notation is. So let's look at the definition, and this is how I like to abbreviate definition. Definition of a set. So a set is a collection of items called elements. So let's look at an example. What does this mean? So this is an example of how we write a set. So these little curly things on the end here, there's one at the beginning here and one at the end, those are called braces. And braces signify, or is the notation for, a set. The parts, or these parts here of a set, are called elements. And we can say these are elements of the set of A. So 3 is an element of A, 5 is an element of A, 7 is an element of A. How many elements do I have? I have 3 elements here. Or let's look at another example. Let's say we have 3, 5, 7, and 7. How many elements do I have in that set? Well, in this set, I have 3 also. Why? Because each element must be distinct from each other. So we have 2 7s here. They're not distinct from each other. So 3, 5, and 7 are the only elements. Also 7. So we have 3, 5, 7, 7. Those are all elements, but the number of elements that we just have 3. Now, there's also something called, we could say we have 3 elements, but there's also something called cardinality. What does that mean? So let's use it in a sentence, which will help us understand what cardinality is. So cardinality of a set is the number of elements in a set. So let's look at this first example here, this one. What is the cardinality of this first example? The cardinality is equal to 3. Now, mathematicians are lazy, and we like to write things simple. Just like when we did A is a set and it consists of the elements 3, 5, and 7. We can just write that as A equals, and then the braces 3, 5, 7. So cardinality can also be abbreviated. And it can be abbreviated the following. So this is notation for cardinality. And the notation we would say is A, so we're going to use these 2 vertical lines here. They kind of look like absolute values. So the cardinality of A is 3. So instead of saying that all out in English. We can just say this in mathematics. So similarly, if we look at this second example there that has 3, 5, 7, 7, the cardinality is also 3 because there are 3 elements within that set. And the notation is also the same. All right, so let's look at sets. Now you saw above, set is a collection of items called elements. Sets, they're written with braces. So you have this, and then you have these numbers in there. So you could have 1, 2, 3, 8, 21, 8. So how many elements would be in that? 1, 2, 3, 4, 5. So they're written with braces. Each item, or each number, or each item, which are distinct from each other as well, in the set is called an element. Now remember, elements are distinct from each other. I'm not sure if that's proper English, but you can help me out in comments and let me know. And let's look at what happens if a set consists of nothing, or what we would refer to as an empty set. What do we do then? Well, an empty set is represented by just the brackets with nothing inside, or a 0 with a hash through it. Those two things would mean that we have an empty set, that it's a set that has nothing in it. Now, let's look at an example. So here's an example. B, and the set B consists of elements 1, 2, 3, the set 3, 4, and the set 5, 6. Now another thing we could add to our list over here is elements can consist of sets. And we see that in our example here. So here we have a set, and here we have a set. So now, how many elements are within this set? So if we're looking at this, we have 1, 2, 3, 4, 5, 6. We have 6 elements. How do we write that? We would write that as this. So how many sets are within, how many elements are within set B? We can write it just like that. Nice and simple. So why are there only 6? Well, this set 3 right here it is a set, and this is also a set. It isn't, both of those, each of those, are elements of set B. Similarly, we have 1, 2, 3, and 4. Those are elements of B. But if you have these little curly guys, that denotes a set. And sets can be within sets and can be elements of sets. But we wouldn't say that 5 is an element of B. 5 is within this set, but it's not by itself. It is with 6, because 5, 6 is a set. They go together. They're grouped together. We can't break them apart. So 5 is not an element of B. The set 5, 6 is an element of B. Now, we can shorthand all of this talking, like set 3 is an element of B. We can take all of that, and again, mathematicians are lazy, and we can set it all with using notation. So let's say all of that using notation. How we would say that is we would write down one of the elements, and we would use this weird looking guy. So it's kind of like a backwards E, but it's kind of like a curvy E. This means is an element of. So that takes place of that whole phrase. So set 3 is an element of B. I could also say 1 is an element of B. 2 is an element of B. The set 5, 6 is an element of B. I don't have to write that all out in English. I can just use simple math notation to write that up. We're going to continue talking about set notation. But first, let's have a reminder of the various number systems that we have. And we have, remember, real numbers, and it's abbreviated R. We have irrational numbers. That's how I abbreviate numbers, is pound sign, or sometimes your hashtag. It's also an abbreviation for number. Q is rational numbers. Integers is Z. And natural numbers is N. Alright, so now we have all of the information we need to talk about now what does set notation look like in mathematics. Now, set notation is taking stuff that we would say in a sentence and putting it into mathematical terms. Again, mathematicians are lazy, and so to, just abbreviate it, or narrow it down so it's easier for us to write. If I have a set A and it has some elements, so we would say set A consists of all elements x such that x is a natural number and x is less than 200. So what does that look like when we want to write that all in set notation? Instead of writing all of that out using words, we can use set notation. So just like the example I just used, we're going to use that example to help us understand set notation. So, set notation. Here's that example. The set A, remember I gotta use my brackets, consists of all elements x such that x is a natural number and x is less than 200. So let's look at these. So out here, we have the curly brackets. So that's signifying that this is a set. Set A. Set A consists of what? So we would say set A consists of all elements x. This vertical line here represents such that. And then we would say x is an element of natural numbers. Again, that's what n signifies, so natural numbers. So, just a refresher, what are natural numbers? Not 0. Examples would be 1, 2, 3, and so forth. So in this case, it would be 1, 2, 3, and then we would read this as x is less than 200. So remember, we have whole numbers, not 0. 1, 2, 3, but x is less than 200. So the whole number that is below 200 is 199. So that's what this is all meaning. And then this part right here, as I just stated, is x is less than 200. Or we can also say between 1 and 199. This is set notation. So we can take all of those words and write it mathematically instead of having to write everything out. So again, this would read, set A consists of all elements x such that x is a natural number and x is less than 200. So let's also look at some sets and what subsets are. And once we talk about those, then we're going to go into some questions and we'll make sense of all of this stuff that we just covered. So we just covered types of real numbers, what set notation is. Now we're going to talk about subsets. First, let's look at sets again. Now remember, sets, here's an example. Here's an example of a set. So we have A equal to 1, 2, 2. That would be considered a set. Let's look at a subset. Now, what is a subset? Let's look at an example. Example, using two sets. So I have this set A, which consists of the elements 1, 3, and 5, and set B, consisting of the elements 1, 3, 5, 7, and 9. So comparing these two, what do you notice? We can say set A is a subset of set B because all the elements of set A are also elements in set B. Furthermore, we could say set A is a proper subset of B. So here's this new term, proper subset. And this is when we have a set. So if we're looking at the above examples, we have the set A and the set B. We would say set A is a proper subset of B because A does not equal B. In B, we have the elements 7 and 9. They're not in A, but A does have 1, 3, and 5, which are elements of B. That we can represent, so if we're talking about subsets, that's like saying we have B here, which again consists of 1, 3, and 5, and then we have A. So A would have like 1, 3, 5, and B would hold these 7 and 9. So A is a proper subset of B because A does not equal B. Let's also look at some notation. Now, I'm going to ask you the question, what if we have some sets, like here we have subsets, but what if we have two sets and they look like this? And we have a set D and a set E, and they intersect right here. How would we represent the terms that are in that intersection right there? So this is an intersection or an overlap. Meaning that D and E have both of those things in common. If we look at intersect notation, this is an easy way of representing this graph right here. Notation-wise, we can write it as D with that upside down U and E. This right here is saying this. So it's showing the set of these numbers here. We want to look at the intersection of those two sets. That's how we represent it in notation. But what happens if we want to talk about all the numbers? So if I want to talk about all of the numbers in the two sets that I have. So again, I have D and I have E, but I want to talk about all of these. Every number. All numbers in D and all numbers in E. So that we call a union. Union notation we use a U and E. So that's representing the whole, both of them together. This is how we use the notation. It is numbers in D and E, the whole thing. That's how we represent it in notation terms. So let's go back to set notation. How would we talk about set notation of the intersecting portion of these two sets? We would say, we would use this term, which would signify to me, ding, 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 we're talking about intersecting. Again, we have to use the curly guys. I'm going to say X, which is going to be numbers. We're going to use that such that X is an element of D and it has to be, X also has to be an element of E. So here's the kicker. And. D and E. So this is the set notation for intersecting sets, where they intersect. This portion right here. How do we write it when it comes to a union? Again, I'm writing this down. It's letting me know I'm talking about the union. I'm talking about the whole thing. Some number X, such that X is an element of D or X is an element of E. So this is or, D or E. So X could be in D or E. So now that we have all of these tools, I'm going to ask you some questions. First question being, I have this set. So here's a question. I have a set, my set A, which consists of these elements. How many elements are in this set? And then I also want you to use the correct notation to state how many elements. So when we say how many elements, what kind of verbiage are we using? I would say the cardinality of A is, so here we have 1, 2, 3, 4, 5, 6. Remember, these guys go together because it's a set. These are sets. So this is a set. So it's counted as 1. So the cardinality of A is equal to 6. Another question. Is 8 an element of A? So if you're looking at A, is 8 an element of the set A? No. And why? Because this set cannot be broken up. This is a set. I can't say 8. Next question. How many elements are within an empty set? And how do we show this in set notation? So how many elements are within an empty set? There are 0. Let's also say 0. So how do we show this in set notation wise? How do we note this? Well, we would say an empty set. So there's nothing in it. Or we could show a 0 with a hash through it. These both signify that there's an empty set. Next question. So I have this set B, and it consists of 1, 2, 4, the set 5, 10, and the set 1 and 2. Which is a proper subset of set B? So here are your options. You have A, you have B, C, and D. So, which is a proper subset of B? So let's first look at A. We have 2 and 4. We have 2 and 4. Do we have a set 1? We do not. So that one does not work. Let's look at B. We have 1, 2, the set 5, and we have 4. Is that correct? That is. Is there any more? Let's look at C. We have 1, 2, but we do not have 5. So C is not an option. Let's look at D. We have 2. Is the set 10 in there? It is not. So D does not work. So B is our answer. B, so this set here, 1, 2, the set of 5, and 4, is a proper subset of B because this set here, this does not equal B. because it does not have 10 in the set 1, 2. Next question. So I'm going to give you a sentence, and I want you to write it in set notation. Set B that consists of all elements y such that y is a positive integer. I'll say that one more time. Set B that consists of all elements y such that y is a positive integer. So, set B that consists of, we're going to have our curly brackets, of all elements y, so we're dealing with y, such that y is a positive integer. So, integer and y has to be greater than 0. So a positive integer is an integer greater than 0. Remember, 0 is not negative or positive, so we can't include it in there. So we can't say y is greater than or equal to 0.